Hey everyone, welcome back to my channel EduVibe. Today we will start with another topic of the electromagnetic radiation, which is from grade 12 physics. So today's today's topic is electromagnetic spectrum and the models of EMR. So this is how the spectrum look like of the electromagnetic radiations. So at the different wavelengths at the different frequencies, we have a different type of things that they have. If they have the highest frequencies, so this can be like not very harmful for us. So we'll learn about this spectrum now. So first we have to learn about the spectrum now. So electromagnetic spectrum. So when we want to look at all types of electromagnetic radiation in terms of the frequency, wavelength, and energy, we will examine that what is known as the electromagnetic radiations. So here's from the electromagnetic radiation can be there. So this is the electromagnetic radiation spectrum diagram. So you can see that we had those from the 10, this is a wavelength. So at 10 meters, we have a radios and TVs. So at this frequency, at this wavelength, we have the radios and TVs frequencies that much low. Then we have a microwaves frequency about 10 raised to minus 1 or minus 2. Here we have 10 raised to power 10, 10 raised to power 11. That range we have in frequencies, hertz. Then we have infrared rate. Infrared rate is minus 5 to minus 6, then 15, 14 something. And then we have that white line. That white line has the visible light, which is originated from the 7 colors of the rainbow. That 7 colors have the different wavelengths of the every color has a different wavelength in this. This is a visible light. So this whole topic, at the topic of the spectrum, that visible light, it goes to the Web graph, which is the rainbow. We learn about this when we do the reflection or refraction. Let's not take too much in this now. And then we have the some highest frequencies or the highest wavelengths we have. So we have ultraviolet rays, we have X rays and gamma rays. These rays are very harmful for us. The gamma rays are very much harmful. So the frequencies that before the visible light are very good, but after that, after these all rays and the gamma rays, these are not very useful, or is it useful but are very harmful. So this is the spectrum look like. But you have to know this spectrum, because you get the when you get numerical questions, they will get if this is the frequency or if this is the wavelength. So what is that from the spectrum? That what is that? This is microwave. This is infrared. This is ultraviolet. You have to know this for now. So electromagnetic spectrum has the 7 forms of electromagnetic radiation we will discuss in grade 12 physics are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and the gamma radiations. That all 7 we have to know in this. So the types of radio electromagnetic radiation range from lowest to the highest frequency and energy. So it goes from radio waves to the gamma rays. We have the lowest frequency to the highest frequency, as I told you. That here we have the lowest frequency, but here at this point we have a very high frequencies. So we go from radio wave, microwave, infra, visible light, ultraviolet, and X-ray and gamma. These are from the lowest to the highest frequencies and energy. So the types of electromagnetic radiation when we range from lowest to highest wavelength. So at this point at gamma rays we have a lowest wavelength. At radio TV we have the highest wavelength. So if we do it like the inverse of this now, from the gamma, rays, ultraviolet, visible light, infra, microwaves, and the radio waves, we get the lowest to the highest wavelength of the in the electromagnetic spectrum. To recall the order of the electromagnetic spectrum, we have a mnemonic for this from the lowest highest frequency, which is a radiant Martin's inverted Venus using the X-ray guns. So this is a mnemonic for this. You have to, like, if you want to memorize this, so you can memorize this. So from this you will know about the lowest to highest frequency and energy. Then you have to reverse of this. You get to know about the lowest to highest wavelength. But the numbers, that some ranges you have to be known, like this from minus 10, minus 1 to minus 4, that range you have to be known from everything. So that's the thing you have to know in this. So we have an example for this. So the ray of electromagnetic radiation has a wavelength of 5.0 10 raised to minus 10 meter in the vacuum. So classify the type of the electromagnetic radiation. So we have the frequency up to like this 5.0 into 10 raised to minus 10 meters. So what's that wavelength of this? So for now, I will show you that the spectrum, but you have to learn this. So we have something 10 raised to minus 10. So 10 raised to minus 10 we have over there, which is the range in the S rays. So this means the type of electromagnetic radiation we have in this is a S rays. For B, determine the frequency of the ovulation of the electromagnetic radiation. We have to find the frequency. So we have the wavelength, and we also have the formula C is equal to F times wavelength. So from here, I have to find the frequency to C upon wavelength. So C is 3.00 10 raised to power 8 meter per second divided by 5.0 to 10 raised to power minus 10 meters. So what's the frequency you get? You get about 6.0 to 10 raised to power 17 hertz. So this is your frequency you get. For C, we have to find the period. So define the period of the evolution of the electromagnetic radiation. So the formula for period is we get this that F is equal to 1 upon T. We have to find that T is equal to 1 upon F. You already find the frequency, put the frequency, have to be put the non-bounded value in this, in that frequency. So we get D as 1.7 to 10 raised to power minus 18, you get 2 digits. And this should be in seconds because period and time is both are in seconds. So you get frequency, you get the period, and you also get the type of electromagnetic radiation from the spectrum. So that's the question you had from this. You use the same formulas we used in the previous lesson. Now the main topic from where the main unit starts, because this unit is all about the models of light, all the waves of light. So they are the models of EMR. So first model is the particle model of light. From the light perspective, we'll do the whole part on the light. So we have to just know about the what is particle model of light. So particle model of light is also known as the Coulomb-Maxwell theory. Was the favorite and preferred model of many scientists of the day, especially the Sir Isaac Newton. So the Newton can be like discover this type of model of light, which is the particle model of light. So this model describes the EMR as the stream of the tiny particles that radiate outwards from a source. So what they said that the EMR is the tiny particles, is the stream of tiny particles that radiate the energy outwards from the source. This particle is discrete unit of the matter having the mass, momentum, and the ability to carry a charge. So you have a carry, they have the ability to carry a charge, they have a momentum, they have a mass. So that particles have the all the things they have to the radiate outwards from the source. Much of the work on the particle model of light came from the Newton, and there was the evidence to support electromagnetic radiation, which is the light behaving as a particle. So how the Newton can say that the any light is behaving like a particle, because the EMR propagates in the straight line, which is the rectilinear propagation. EMR can be reflected. How it can be reflected, we will learn more about this when we do reflection. EMR can be absorbed. The EMR can also be absorbed. We absorb that EMR also. So because of these reasons, the Newton says that the EMR is behaving like a particle. From here, they discover the particle model of light. Newton used the hypothesis that for light to travel in the straight line, it must be really very fast. They also tell that they also like predict that the light is traveling in the straight line, so that means they have very far travel very fast in that case. So that's all the Newton can say that theory about the particle model of light, and that you have to know in this. This is some theory part you have to know. And the next model of light is wave model of light. So they also have the wave thing. So EMR is also behave like a wave. Sometimes say that. So in 17th century, another theory proposed that EMR as a stream of the transfer waves. Transfer waves is later these type of waves. That straight waves you have like very nice curves we have. So this stream of transfer waves we have, that something say that the EMR is a stream of the transfer waves, radiating the outwards from a source, which become known as the wave model of light. So some scientists they have the perspective of that this is a stream of the tiny particles which radiate outwards from the source is called the particle model of light. Some says that the EMR is the stream of the transfer waves radiating outwards from the source and becomes the wave model of light. So that's all the theory they have. So the modern wave model of light has its origins with the Dutch mathematician and the scientist Christian Huygens. He argued that the high concept of the waves that the light waves could interfere and produce a wave front traveling outwards in a straight line, just like the particle model of light. The wave model of the light also evidence to support his position. That they say that they both try to argue that the light is also considered as the waves, and that light waves are interfered and they produce the wavefront. They produce a wavefront. So the light can also be compared with the waves. So they from traveling outward with a straight line too. So from here they also support the evidence too that EMR is under the diffraction. So what is diffraction? Diffraction we learn in this unit in later on. So EMR can also be polarized, and EMR interferes is would be absorbed between the electromagnetic waves. The electromagnetic waves topic we'll learn more about this. So that all the theory, that all the sporting things they ask further that we have the wave model of light, which then say that the EMR is behave like a waves. So that both theory, now we integrate the both theories. We learn more about how many theories they all the scientists can be done in this. So at the end, we will conclude that if the EMR is uh, behave as a wave or it behave as a particle. So we learn both things about side by side now. So this is all know for the theory part now. For now, you have to just know about the theory part of this because you get often the questions from this topic. So that's all for this lesson. We introduced the models of EMR now. So in the next lesson, we will learn about the speed of electromagnetic radiation. How can that 3.00 10 raised to by 8 meter per second, that speed, how it discovered and who is discovered this thing. So we learn more very important experiment in that. So this is for all for this lesson. Like me say where I do vibe, learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with Edu Vibe.